Okay, so this is a problem from your tree diagrams homework in ALEKS. And I thought that it was really challenging, so I wanted to help you guys with a video. It says the percentage of people in the population who have a certain disease is 30%. There is a test for the disease that is fairly accurate. Okay, so first they have the disease, or they don't. Then it says, of the people who have the disease, who take the test, 5% of them do not have the disease. So it is wrong. It says, of the people who do not have the disease, who take the test, 10% of them do have the disease. Okay, so let us see if we can make a diagram of that information before we even bother to answer this follow-up question. Okay? So, first we'd look at a tree diagram where someone has the disease or they do not. Then we look at whether or not they tested positive for the disease or not. So then we look at someone who tested positive or not. So in this case, we know that 30% of the population has the disease. So 0.3 would go there. If 30% of the population has the disease, then the other 70% of the population does not. I found that by taking 1 and subtracting the 0.3. Each of these branches is complements of one another. Now we must read the second sentence with numbers in it carefully. Of the people who have the disease, that's my top branch, who take the test, it reports 5% of them do not have the disease. So it says, even though they're sick, that 5% test negative, which means the other 95% test positive, or 1 minus 0.05. One final sentence with numbers in it, and then we're ready to try to understand the chart. Of the people who do not have the disease, that's the bottom row, who take the test, it reports 10% of them do have the disease. So we're reported that 10% do test positive, which means the other 90% do not. So again, that was 1 minus 10%. So what do I now know about this? I now actually have a series of several probabilities at the end of each branch. The end of this branch says that this is the probability of someone who has the disease and tested positive. That would be 0.3 times 0.95. This is someone who has the disease and tested negative, which is 0.3 times 0.05. This third branch is someone who does not have the disease and still tested positive. That's 0.7 times 0.1. And I will fill these answers in 1 second. The last branch are people who don't have the disease and they tested negative. So that's 0.7 times 0.9. I know that this is 0.07, and I know that this is 0.63. The others I do not know how to do in my head or don't want to, and therefore am going to use my calculator. The second line is 0.015, and the first line is 0.285. Okay, so We've made our tree diagram, and we now know what probabilities lie at the end of each branch. Let's finally answer the question. So I'm going to draw a line here around our diagram to say, this is my picture. Okay? Everything else comes from what we already know. Suppose that a person takes the test and it reports they have the disease. Hold up. That is crucial. Given they have the disease. Excuse me. I'm sorry. It reports they have the disease. That's my fault. I misinterpreted it. Whew, this is why this problem is tricky. Given it reports they have the disease. Given they test positive. This is the tricky part about this problem. So it's given that they test positive. Then it says, compute the probability. So find the probability they do not have the disease. All right. So two things are needed. And right at the bottom, I'm going to rewrite our formula for a conditional probability. It says A given B would equal the probability of A and B over the probability of B. All right, here goes for our example. Let's choose blue for the rest of the example. Ours looks like this. The probability, and said, given they tested positive, what's the probability they don't have the disease? So right under there, I'm going to write our formula. Well, that means that they don't have the disease and they tested positive in the numerator, but the denominator is the probability that they test positive. So the trick to this question is that the numerator is line 3. This is someone who does not have the disease but did test positive. That's my numerator. The problem here is that the denominator is all of the possible ways to test positive. So you can test positive and not be sick, like we saw in the numerator, but you can also be sick and test positive. So we need to include all the ways for someone to test positive in the denominator. So we do have to add 0.285 plus 0.07 to find our new denominator. So this will be 0.07 divided by 0.355. So 0.07 divided by that gives me, I'm going to approximately say we've got 0.1972. That would be the probability that they don't have the disease given they tested positive. And that would be the answer to this particular online homework question. Hopefully this helps.